Good morning, GIS 300. Time for the long-awaited lecture on patterns in point data. And the way I'm going to present this is in a way that I hope applies to your final projects. I know at least some of you have project questions that could be at least partly addressed with these tools. So I'm going to go one tool or one group of tools at a time, covering 3 or 4 of these, and hopefully you can find some application to that in your final project. Before we get going, some keywords. One is random, and that is a pattern that exists purely by chance. There's no underlying process that attracts points to a particular location. If you think of points being the coordinates of trees, if you scattered seeds everywhere at random and all of them sprouted, that could be a random distribution. If you have all of the trees coming from one tree in the middle of an open field, there's going to be more seeds falling closer to the tree and fewer falling farther away from the tree. Likewise, if you're in a desert and there's an oasis here and enough water to sprout, that's a pattern. There's going to be a process that drives where trees or where seeds can survive. And then farther away from that, less survival. So there's a pattern there. And that would not be random, but a random, just scattershot, no pattern, no process driving the distribution of points. Pure probability. A significant value, that is using what we understand about probability to say that there is a real difference between either this data set and that data set, or this data set that is real and this hypothetical data set that is made up based on random distributions. So that is an underlying concept in all of comparative statistics, and not to get too deeply into that, but you are looking for a real and reliable difference, not one that could have occurred by chance. So that is the key difference. I see men are taller than women, or spruce are taller than fir. Could that be down to chance? Spruce being taller than fir, maybe. They tend to grow about the same, but men do tend to be taller than women. So if you measured a bunch of men and women, you would probably find that there's a difference between them in height that is not explained by random chance. There's an actual pattern there. So when we say a difference is significant, a statistical test has been applied, and we've used the patterns of probability that we understand to say that this difference is real, and it's not something that occurred purely by chance, or that it is not likely to have been something that occurred purely by chance. That gets into a confidence interval question. But when we say there's a significant difference, we're usually saying there's a 99% chance that it's not occurring purely by random opportunity, or a 95% chance that it is not a purely random by chance observation. And that means that 5% of the time, or 1% of the time, depending on what threshold we set for calling something significant, there is going to be a false positive, which means that we say there's a real difference, but, well, sometimes when you roll the dice, you get 100 ones. So that is that. And again, we've talked about spatial and temporal before, but just to review, a spatial thing has to do with the distance between things, or the adjacency between things, the physical relationship in space between them, versus a temporal change, which is change over time. And some of you are dealing with strictly spatial questions, and some of you have temporal questions, and some of you have what are spatio-temporal questions, which involve both space and time. And now we're ready to go into Star Trek. That didn't take long. So we are going to be working with the Cumberland County census blocks from 2010. Let's take a look at that. But let's do that in the next video. So I'm going to go back here, and this one